Hi all, good morning, good afternoon, and good evening. Yesterday we have discussed regarding the over-replicated as well as under-replicated, right? So how it will be solved also we have discussed. The number of blocks is less than the replication factor. That condition we can set it under-replicated, and the number of blocks greater than the replication factor we can set it over-replicated blocks. And over-replicated block can be resolved, can be solved. That the issue can be solved internally. Okay, the Hadoop framework will be do. It will not errors to solve the issue as soon as possible. It will be in deleting one block internally. It will take its own time. And the under-replicated block can be solved by adding one more data node, or we can change the replication factor. If it is 3, we can change it to. That way we can solve the issue. And we have installed the the guest edition yesterday, right? Guest edition we have installed today. While what we'll do is etc host file. So this document may be confusion for that. Okay, this is the other host name. We are going to do the multi-node cluster. That's why I have made an entry of this one. Okay, just let's see what is the host file. Vi etc. See, this is the ipconfig. Ipconfig is the command to see the IP addresses. Ipconfig, this is the 5. Okay, 5, and machine name is VM1000. Okay, so sudo vi, I think sudo you have done. So then su, then server vi. Vi is the editor in the Linux, Okay, host. Etc host means this is the host file. Host file means what is the host name of the file. We can make an entry. Okay, so that the resolution means so host name to IP address to be happen here. That's why I will make an entry of this host file. So what is the entry here? The IP address, already the IP address. Okay, let me open the terminal. Ipconfig 192.168.0.5. Copy, excuse me, 5. And what is the host name? Host name is VM1000. Okay, VM1000. This is my host name. Okay, 1000 VM1001. Okay, just for time being I'm entering this only. Okay, because I'm going to do the single node cluster, then I can add some other nodes. So in this document I have mentioned multi-node because I'm going forward I'll add two more nodes or two more clusters. That's why I'm just building. Okay, and the IP address is 5 and the name is VM1 1000. Okay, what is that? VM1000 VM1000. Okay, let me see what I have entered. Cat slash etc host means we can read the file. VM1000 I have entered. What is the requirement to solve the if I ping this one with this host name, it will be pingable, or you can ping this one also. It will ping means it can resolve the host name to IP address or IP name to host name. We are not integrating with the DNS server. If might have you know about the DNS server. DNS server, if you integrate with the DNS server, automatically it will resolve the name to host to IP, because we cannot remember all the IP address while typing Google. You are not remembering Google IP address, right? So that is called friend name. Suppose ping google.com. So you don't know the IP, right? Now IP got it. This is the IP address from the Google. Okay, suppose, okay, I'll ping this IP address, ping hyphen a IP address. If I'll do, it is pinging to google.com only. Okay, so this is the server name. This is the server name. Just see, this is the Google server name. Ping ping hyphen a. Sorry, this one also you can give. this resolution will happen. Okay, because nobody can remember the IP address of this machine. Okay, it is pinging. So -a google.com, sorry. Okay, I'm getting one IP addresses. If you ping this IP address also, it is pointing to the Google server, google.com. Okay, the same way to resolution. For resolution, there is a server called DNS server. Okay, domain name system, DNS server. But here I am not doing DNS server, but I can make an entry in the etc host file so that it can resolve the issue. Then now stop the IP tables. So what does it mean? IP table means some of the services cannot be allowed. Okay, cannot be allowed by the IP table because IP table by default it is enabled in the Linux machine. So you need to stop this one. Paste. Okay, IP tables means if I will not stop this IP table, sometimes I'm unable to run some of the services. Some of the services means maybe Hadoop software while installing, it may block that Hadoop application, or some other applications like any Java process may be blocked, it will be not allow. So this is by default, it is a security system, but I need to stop here so that it can be allow other process to run. So that is the point here. I'm just stopping the IP tables done, and permanently I have to flush the IP table. Means if there is a catching, okay, in the cache or somewhere there, if the IP table is there, if it is existing, it will be flush. Means if there is a the IP table rules are there. Okay, some of the rules are there, which website or which application will be allowed or not. That will be there. That table, if there is existing table, it will be flushed from the memory. Just it is done. Now I have to stop it permanently. Okay, this is the command. So now at this condition, if I will reboot this system, in this condition, if I reboot the system, my firewall will be, my IP table will be again in a enabled state. It will be in a active state. I stop now and I flush the from the IP tables will be flushed by executing this command from the memory. If there is a table exist, it will be flush. Now if I reboot the system again, it will be activate. The service will be again activate. I need to stop. So to do that, to permanently stop, okay, permanently you have to stop the services by executing the command check config chk config IP tables off. If I'll execute this command, if I reboot the system also, this IP table service will not be activated, or it will be not start the service. Okay, that's why I have given this permanent change. If you on it again, it will be activate by executing this command check config chk config IP tables on. If you do on again, it can be activated. So now you can see whether that Java is there, or because the Hadoop framework is written in Java language. Okay, that's why I need to check it out whether the Java is there or not by executing the Java command. Java is there, I think so. Yeah, because I'm getting the help lines. Okay, so Java is already there, but Java C command is not executing. Means Java C means compilation is not happen by the Java C. So if the Java C is not, means there is a Java JDK, Java development key is not installed in this machine. So I have to install the Java development key, and you can see Java version, Java hyphen version. Yeah, it is a Java version. Okay, this is the Java version 1.7, but I need to install JDK. Okay, Java development kit. This is the runtime environment. Means if you open one browser, that browser also depends upon the Java. Okay, so this runtime environment Java is there, but there is no JDK. Java development kit is not in. There is no Java JDK. Okay, but runtime Java is there. So I need to install the JDK, Java. Okay, so what is the command? This is the command to install the JDK. Let me execute. Copy paste, yum install. Okay, yum install, this is the Unix command to install the software from the repository. Yum install java hyphen 1.7.0 open jdk devel. Okay, this is the command yum install. This way we can install the software. So it will be connected with the internet and it will be downloaded from there and it can be installed. Hit enter. Now it is installing. The JDK is installing. 1.7.0 open JDK level. So 36 MB of file will be installed. Say yes. Java is required, okay, because Hadoop is written in Java language. Install and failed something. So Java, she could not find Java lib. So okay, Java coming. Java version is also coming, but before what happened? 1.7. Okay, I think it was there. Var lib locate database no such file or direct. Cannot start. Okay. User. Yes, I leave. Yeah, this is the location of the Java. cd Java 1 hyphen 1.7.0. Okay, nothing is there. cd jv. Yeah, this is the location of the Java pwd. So usr leave jvm, and this is the Java 1.7.0 OpenJDK x86 x86 underscore 64. This is the location of the Java where my Java is installed. Like Java. Now Java is coming. Okay, compilation is not happening. Maybe reboot required. But yeah, Java is there. cd Java for 1.7.0. Yeah, there is a bin file. Bin Java C. Could not find leave Java. So maybe some problem. Okay, but fine. For time being, it's okay. Java. Maybe reboot is required. Okay, so this way we can install the Java. I'll if any error will occur while um, running the services, I'll rectify that issue. Now what I'll do is I will create the group because Now what I'll do is this is my system. Okay, just I'm making it ready. What I did, like the guest edition OS I have installed, OS installation done, guest edition also done, and after that the etc host file. Okay, etc host file I have made an entry, host file, then Java installation also done. Now what I'll do is, to manage this system I need a username. Okay, I need a username. So I will create a username username called hd user. Okay, hd user. And for that user, in that user I can create one group. In that group I can add many users. So for group also I need to create one group for easy administration. Okay, so that I can add many users, so many users can log into the system or they can manage. So for that reason I can create one group called Hadoop. Okay, the group name is Hadoop. Anywhere in, like in Windows also you can create the groups, and you can add many users into that group. The same way I can create one group called Hadoop and that user, and I give the permission to the users and groups. Okay, that I'm going to create now. So what I'll do, just I'll create the group name at group name is Hadoop, Hadoop. Hadoop. This is my group name. Okay, if I create user first, what will happen? When a user is created in the Unix machine or Linux machine, a default group with the same name will be created. Okay, so that is called primary group, but this is a secondary group, you can say. Okay, just I have created the group first. Okay, then I can create the user and I can add user into that group. Group has been created, and user add, i'm I'm adding. Okay, group has been created, I'm adding a user to this group. User add, then hyphen g, group name Hadoop. Okay, then username is hd user. So hd user is a user who is going to add into the Hadoop group. Hit enter. Okay, now in this group, in Hadoop group, user hd user is added. Okay, that is the thing. Now I can assign the password for this hd user. Okay, what is the command? passwd password hd user. So hd user is the user who is going to manage the cluster, and I'm going to change the password for that hd user. Password you can give hd user, again hd user. You can give anything in the company level or in the corporate level. You have to give a complex password so that nobody can guess it very easily. hd user. Okay, the password has been successfully created or updated. So I have created this user. Okay, I wanted to give some permission, some kind of privileges, like as a root. So that is called super user. Okay, super user is nothing but like user, root user. He has, it can get the all the permission. He can do all the things. All the administrative tasks can be done by the HD user. So this is the command vi sudo, vi sudo. If I'll make the entry of the HD user, okay, he will act as a sudo user. Okay, vi sudo. Hit enter and go to the line, and you can go to the insert mode. Insert means I. Okay, you can make an changes here. Just go to the location where you have to change. Just see the root. Okay, the root user, I have logged in as a root. Root user has all the permission. He can execute all the commands from everywhere, and all the tasks can be done by the user, root user. Okay, the same way I wanted to give the permission to hd user, which I have created hd user. Okay, user. hd user is the, like I'm making is a super user. All he can anywhere anywhere he can do all the things, means all the tasks. He can execute all the commands. Okay, he can do all the commands from everywhere. he has the access. Okay, he has the privilege to do all the things. So now I can say escape. Okay, in your keyboard you can put escape. Insert is gone. Then shift colon WQ and hit exclamation, means forcefully I'm saving and quitting from here. So vi sudo, in that vi sudo, the hd user I have made an entry. So now hd user is act like as a sudo user, okay, super user. Now we'll install the Hadoop software. So probably tomorrow I will take you this one, how to install the Hadoop software and how to do the setup. Why? Because if I'll do, it will take some more time, one thing, and I need to discuss some more things to come to this point. Okay, so we'll discuss that one. Now exit, exit, exit. Okay, now just log in, log off this machine, system shutdown, Hibernate shutdown is there. So what I'll do is I will lock the system. Is there anything? Tools, show HD user. Sorry, so HD user. HD SER. Now see, I have navigated as a HD user. What the user I have created, I'm logged in to this system as a HD user. Before I have logged in as a USER user, normal user, right? And if you want to navigate to as a root user, so dash space dash and give the password server. You are logged in as a root. Okay, this is the username at the rate system name. Okay, and this is the home directory. PWD is the present working directory. Slash root is the present working directory. I'm exit from here now for time being. And we'll discuss some of the things. Then only we can install the Hadoop software. So now user creation and group creation also done. In Hadoop, there are three modes of the Hadoop distribution. There are three modes. Okay, the setup means the cluster setup I wanted to do. Okay, how to do that? So for time being, we'll discuss about that. So there are three modes of Hadoop cluster. So Hadoop cluster can be done three ways. One is single user mode, okay, or standalone mode or local mode. Okay, I'll tell you why. What is that? This is a single system. Okay, this is our machine, one machine. In that machine, I can install the OS. Okay, I can install the OS. I did the all the settings, changes, everything, whatever the software is required, I have done. And apart from that, I have installed Hadoop software. Hadoop software. Okay, I have installed, and I make this system as a Hadoop cluster. So you can say it is a standalone mode. Means it is not a cluster, but it will be just I have installed the Hadoop software, and there is no HDFS file system. There is no HDFS file system. Just it will be I have installed the Hadoop. So this type of setting we can say it is a local or standalone mode. Means this is used for the debugging purposes. There is no HDFS file system. Okay, just it will be depend upon the local file system. Local means in this, in the hard disk of that local machine, or the file system of the Unix file system. Okay, the OS level file system I can access, and I for storage and processing it can be utilized, and there is no HDFS file system at all. So this mode we can say standalone mode. Okay, go to the slide. What is there? This is the local and standalone mode used for the debugging and testing purposes. Suppose that if you want to change something, okay, as a developer, okay, as a developer, if you are a Hadoop developer or Hadoop software developer. Okay, if you want to modify something or you wanted to add some feature into the Hadoop cluster, Hadoop software, then you can utilize this mode. Means just you have to install the Hadoop software and you can do some modification. Whatever the modification you wanted to do on the soft application level, you can do that. Hadoop application level, you can do that. So HDFS is not being utilized in this mode. Means there is no HDFS file system. There is no distributed file system in this mode because it can be rely on the only local file system. Okay, the Unix or Linux file system, the local uses local file system for input and output. We cannot get the Hadoop distributed file system. And and this is the configuration file we will talk about later, but for time being I'm saying it is not utilizing any of the configuration files. Means we can have the replication factor 3 and the block size is 64 MB and many of the parameters, and where I can store the data node file, where I can store my metadata, all those things cannot be defined here. Okay, it is the default mode of the Hadoop. Standard mode is much faster than the pseudo distributed mode. What is pseudo distributed mode we'll discuss in my upcoming slides. So here this is called standalone, means only the OS and the Hadoop software is installed. It will not utilize the HDFS file system. It is only accepting, only utilizing only local file system or the OS level file system. Okay, this is called standalone mode. It can be utilized for the debugging purposes. And the second one is pseudo distributed mode. Pseudo distributed mode in the sense what will happen here, the same thing. Okay, I can install the software OS and all the settings I can do it. Okay, okay, everything I can do. And here what will happen when you install the Hadoop software and you can change the configuration files, it will depend upon the, it will utilize the HDFS file system. Okay, it will utilize HDFS file system, means all the configuration changes, all those things can be done in the pseudo distributed. This is called standalone or local mode. Okay, standalone mode, stand mode. This is called pseudo distributed mode. Okay, I have installed the Hadoop OS and Hadoop software, and here I can utilize the HDFS file system and for the processing component also there, but it will work in a single system. Okay, the pseudo distributed mode, it will work in a single system, but it can process, it can create the processes, all the process, like when we do the Hadoop software, I can have the data node, name node, secondary name node, and job tracker, task tracker. Job tracker and task tracker I have not introduced. That is called processing component. Okay, we have not installed. For time being, I can say data node, name node, secondary name node, all the daemons, all the services I can facilitate in a single system. That is called pseudo distributed mode, and it can utilize the HDFS file system. Okay, so that is called pseudo. So it is used for the testing and development purposes. So testing and development, what they will do, when the developer or tester wanted to test something in the Hadoop cluster, you should not give all the machines. You should not give the production servers. What you'll do, just you can install the software and you made some changes, all the configuration changes can be done, and you can hand off to the developer or tester so that they can do the testing. A small piece of data can be tested over this system, so that logic can be applicable for a huge number, huge amount of, huge cluster, or multiple nodes of the cluster or multi-node cluster, it can be applicable. Okay, that is called pseudo distributed mode. So all the Hadoop daemons such as name node, job tracker, task tracker, data node, all the daemons, second name node. So this is one single individual systems. Okay, the process, it will be running in a single node. Okay, it will be running in a single node, and that process we can set is JVM, Java Virtual Machine. Like one process, one Java Virtual Machine will be created, and all the process will be running in that mode. Okay, in a single system. All the master and slave daemons will be running on the same node, means in a single system. This mode is mainly used for the real testing and development purposes. Replication factor will be 1 for the blocks. Suppose here in the replication factor I can set 5, 6 or 3. What is the use? Because I have only one system. So if you put the 100 replication factor is also 100, there is no use because I have only one single system. So by default the replication factor will be 1. That is the point here. HDF is used in the inputs and output. For storing and processing, we can have HDFS file system here. And the changes, configuration changes like HDFS .xml, course.xml, that we will discuss. But that is the configuration files. What is the purpose of the configuration file? The purpose of the configuration file is to override the default values. Okay, suppose the replication factor is 3. That is the default one. I wanted to make it 4. I can do that very well by utilizing by using the configuration file. Okay, so that is the purpose of the so there are lot many configuration files are there, we'll discuss. So that is also part of pseudo distributed mode. Pseudo distributed mode can be installed in a single machine and single JVM. All the process like job name node, job tracker, task tracker, data node, secondary name node, all the daemons will be running in a single machine. But we can have the feeling of Hadoop cluster that can be utilized by the developer and tester for testing purposes. Okay, any doubts in the pseudo distributed mode? Okay, now coming to multi-node cluster. So in multi-node cluster, as the name says multi-node, so I can have different nodes. I can have name node. Okay, all the um, all the processes are running in the dedicated machines or multiple of machines. Here this is the second name node, secondary name node. Okay, and these are the data nodes. So how many number of data nodes you require, you can put that way. So for time being I can take 3 data nodes. Okay, and all are connected with each other. And it is connected with the name node as well, name node to secondary name node. So as a whole, all the connectivity is done from one to one or one to many connections are there. So now here data node, this is data node, and this is data node. Now the data node daemon is running in this machine, and this is I am facilitating as a data node. That's why the data node daemon is running in this machine, and data node daemon is running in this machine. What is daemon? Daemon is nothing but a background running process or internal process. Okay, the process, like if you open here the browser, there is a process running in the Windows machine like that. Data node is a service or it is a process in the Unix or Linux concept. I can say it is a daemon. So data node is a daemon running in this machine data node, in this machine also the daemon is running, and the name node daemon is running in this machine, and secondary name node name node name node daemon is running in the secondary name node. So all the daemons are running in this separate machine, and all the processes are running different or separate JVM. This name node daemon is running a separate JVM. Here also it will create separate JVM, separate JVM, separate JVM, separate JVM. But in pseudo distributed mode, all the daemons are running in a single JVM. If one service goes down, all the services will be terminating in the pseudo distributed mode. Again, you have to run the all the process. But here, if name node daemon is running, only I can start the name node daemon in this machine. If my secondary name node daemon would be stopping, I can start again in the secondary name node. It will not affect all the data node daemons. Okay, if this data node daemon is not running, I can start this data node daemon again, but here all the data node daemons will be running properly. Here name node will be running properly, secondary name node will be running properly. So it will be not affect to the, if this data node daemon is stopping, it will not affect others. This because this is an individual service, individual JVM. So all the respective daemons will be running in the different nodes. So that is, and it can be utilized the HDFS file system, and it utilizes the distributed file system. Okay, that is That is called fully distributed mode, or you can say it is a multiple of machines. Okay, what is this, right? It is a master slave architecture. As you know, name node is the master service, second name node is the master service, and remaining data nodes are the slave service. So you can say it is a master slave architecture and will be running on the separate nodes in the Hadoop fully distributed mode. Okay, thank you. So the last mode is fully distributed mode. It is a master slave services and will be running on the separate nodes in the Hadoop fully distributed mode. It is basically used for the Hadoop production phase for the Hadoop cluster. Means it can be deployed in the production environment. So it is not used for the testing development purpose because it is for the production usage. For the business of the company, we can deploy the multi-node cluster. So for the master and slave daemons will be running in the separate machine, and the replication factor would be 3. And if your company or management requires more than that, you can very well do the setting of replication factor 4, 5, 6, like that. We can increase or decrease as per your requirement. Different nodes will be used for the name node, job tracker. I have not discussed that components, but we'll going to learn tomorrow. So means all the components, different daemons should be running in the different separately or dedicated machine. Okay, that is the point here. And the master daemon is name node and job tracker and secondary name node. Job tracker that I have not introduced, that's why I have not talking about here. But name node and secondary name node is the master machine daemons, and data node and task tracker Data node daemons is the slave nodes. Means all the daemons, the point is here, all the process or daemons are running in the separate machine, and we can have data. Uh, Data can be stored in the distributed fashion across all the nodes or across multiple of nodes in the Hadoop distributed mode or multi-node cluster. So any doubts in the like standalone mode, pseudo distributed mode, and multi-node cluster? So this setup we can set is a multi-node cluster. It may be two machines also. I can make a multi-node cluster. Okay, this is I have taken four nodes, one, two, three, four, 5 nodes. I can make a multi-node cluster. Otherwise, I can create another multi-node cluster with this setup as well. How can I do that? I can make it very well this one. This is one node. Okay, I can take another node. Okay, this way also I can make it. What I'll do is I'll make this is a name node, and I can make this machine as a secondary name node as well. Okay, I cannot get that much of flexibilities like separate machine, but I can do very well here. Data node and task tracker. Task tracker, I'm not introduced, but still I can take it as a data. I can make this machine as a data node. Okay, so that I can have achieve parallelism of storing data node. I can make this one as a data node and this one job tracker and task tracker JT. This is the processing component. Tomorrow we can discuss about that so that you can be clarified. Means I can make this machine as a name node, second name node, and data node, and this machine is a data node for time being. I can do very well. So this is also called a multi-node cluster, right? I can have HDFS file system and distributed across both the nodes. The data will be distributed across both the nodes. So I can achieve parallelism here as well. So this is also called multi-node cluster. Okay, if you have any doubts, please let me know. Otherwise, I can go for other topic like the read operation. How the read operation will happen in the HDFS file system. To read a file from HDFS file system, what will do? The client needs to interact with the name node. The first point of contact would be the name node. Okay, the first is already we discussed. The first point of contact would be the name node. The client will contact the name node saying that, hey, name node, I wanted to read the file which is stored already inside the Hadoop cluster. But the name node, what it will give? It will say that I have no data, but I have the information where the data stores I know. So the name node will give the complete address in where that client can read the data. So there are three copies in that three different machines of a single block, but it will point to one machine because one machine having one block, it is more than enough to fetch the data from that single machine for the single block. For the other blocks, it can depend upon other machines. So that pipeline or that address will be given by the name node, and it will be uh, you know get the information from the name node by the client, and the client directly will go to the data node and contact it to the respective data node because it has already had the address of all the data nodes where the data blocks are present, and directly it will go to the nodes and it can read the data. Okay, so this way the read operation will be happen. So if you go for internally the that more technically, this is the way. This is my HDFS client. Okay, HDFS client is nothing but a system where I have installed the Hadoop software so that I can make a client. So there also I can have the process, it can be run. Okay, the JV means Java Virtual Machine, one process or one internally like one VM or virtual machine or virtual processor. We can say virtual means it can have the all the resources like CPU, RAM, hard disk. Okay, that kind of, so that is called client or JVM, Java Virtual Machine, that is created. The client is sending one open request saying that, okay, I wanted to read the file. So one open request will be fetched by the distributed file system. Means the file management can be happen to the file system. Suppose you are putting the data, you are storing the data in your laptop. Okay, you are putting the data. So are you going to internally how it is happening, are you going to control? No, just you are putting the data in C drive or D drive or E drive. So who is taking care, who is giving the index, who is internally giving the address kind of thing? That can be taken care by the Windows file system. What is the Windows file system? It may be FAT32 or NTFS file system. So that file management can be done by the file system. Like similarly, here also the file system will be taken the control. Okay, one open request means the given read request will be generated from the client machine saying that I wanted to read the file which is stored in the distributed file system or Hadoop cluster. So it will be pointing to the distributed file system. The file system will be accept that request and it will be fetched to the name node. Okay, get block location means it will contact to the name node because first point of contact is name node. Now name node having the information of about all the data blocks where it stores in which data node it stores because it will read the metadata from by the name node name because name node keeps the metadata, so it will search the index, search the metadata and giving the address to the client machine saying that go ahead and fetch the data. So now what will happen, the read request will be fetched through the input stream. Okay, there is the internal concept we can say in the file system. It will be channel, one channel will be generated means one tunnel or one path will be created, so that is called fs data input stream. So stream in the sense like pipeline. Okay, so one tunnel or one path will be open to read the file. So already the client machine having the address from the name node, and in this case it will be go to the data node 1, a data node 1, suppose this one say 1 or this you can say it is a 3 or third machine. Okay, so it is going to for the first block from it will be read from the data node 1 and the second block it will be read from the data node third, and this both the blocks is the complete file. Okay, this both blocks complete file, that way it will be read by the client. This is the internal mechanism. Okay, any doubts here how the read operation will be happening in the Hadoop cluster? Okay, fine. The write operation, it is almost like the similar. Okay, but what is the first point of contact? The name node. Okay, when the client wanted to write, if you wanted to upload or write the data into the Hadoop cluster, what it will do, it will contact to the name node saying that I wanted to write the file, my file having so and so blocks or so and so size like 100 GB or 100 MB or 200 MB, whatever may the file size, it wanted to write the data. So the name node what it will do, because name node having all the information about the all the machines, about the data about the address of all the sleep nodes and what is the load at this particular point of time. So all the information is there, so name node can take the decision where it can write the data. Okay, where the client can write the data at this particular point of time. So it selected the name node selected data node, suppose data node 2 and data node 5, maybe there are 5 nodes, so it can choose 2 nodes or 3 nodes. What is the requirement, because at this particular point in time which node having less burden, which node having less work pressure, it will be choose. Okay, by the name node or by the framework you can say. So it can be chosen and given the address or given the name data node address to the client machine, and client now will be sending the blocks or sending the file to the different data nodes. From there, when the first block, okay, when the first block or zero block you can say, the first block is written into the data node 1 or data node 2 or anywhere, from there the replication will happen because replication factor is 3. So the replication will be happen sequentially one after another, it will be right. Already we have discussed on that. So that way the write operation will be happen internally. If you discuss what is it, this is the JVM client or client machine. It will be create one request. Okay, it will create one write request. It will be go through the distributed file system to the name node saying that I wanted to store the data. Okay, the name node having the information because it cannot store the data, that's why it will but it has the information about where to store the data. So now the name node is given the complete information. Now client will write the data through the output stream, means it will create one channel or it will create one path. Through that the write request will be go to the data nodes because already I have the address. by the from the name node. Okay, so I can choose the data node 1 or data node 2. Suppose I have two blocks I want to write, so it can choose block data node 1 and data node 3, suppose. So now the first block is written, okay, written in the machine in the simultaneously in the same time or in the parallel way. It can be written in the second block. Now the first block of 0, first block and second block is written very first time in the data node 1 and 3. From there what will happen, the replication will be happen, because I know the client has the information, the pipeline information, means where the data will be replicate, that information also there by the name node. Okay, so it has the information. Now what will happen, from the data node 1 to data node 2 or data node 2 to data node 3, like that in this example it will be replicate. So the replication will happen pipeline. Okay, replication will happen sequential. The same way data block 2 will be written here and it will be replicate data node 2 and data node 1, like that. It will be in this example I have taken 3 only. So if there are multiple of machines, that way it will be happen. Okay, the replication will happen sequentially one after another. So once the write request, one the write of the block, the third block means the replication factor 3 means it's the third block. When written into that data node, the acknowledgement will be coming to the second node saying that whatever the pipeline you have given, I have written successfully. That block is written. Then from the second node to the first node, it will come saying that okay, whatever the pipeline you have provided me, I have written the data. I have written successfully written that block. And at last, the data node 1 will be send the acknowledgement saying that I have written the data, whatever the data block you have given, I have written successfully. And the same acknowledgement will be sent back to the name node. So that name node will update in their metadata saying that I have 3 copies and which of the data node it is written. All the address will be updated in the as a form of metadata. Okay, this is called write operation in the HDFS file system or in the Hadoop cluster. So this way it will be happen. So when already we have discussed about the replication factor, how the pipeline is happening. Okay, one after another it is happening in sequentially. So the complete block is not transferring. Okay, the point is here the complete block will be not transfer from data node 1 to 2. What will happen internally exactly, it will be transfer the data with 4 KB of blocks, like 4 KB, 4 KB, 4 KB, and it will complete like it is 64 MB. Okay, then again from second machine to third machine, like 4 KB, 4 KB, 4 KB, 4 KB, up to 64 MB. Okay, that way it will be write the data. If you go for very internally, that will happen. But I am saying from here this machine to this machine will be replicate, from this machine to this machine replicate. Okay, but the fact is same. But if you go for default, the replication will happen very low bytes, like kilobytes. 4 KB, 4 KB, it will be replicate one after another, one after another, and the write request will be completed. And the acknowledgement is sent back to the previous node, previous data node, and from that node to the first node. And the acknowledgement, the complete information, like the operation be successfully completed, that acknowledgement will be back to the client as well as to the name node. And name node will be updated in the metadata, having all the nodes information, all the replica information, everything will be updated by the name node. This way the write operation will be successful. Any doubts here? Please let me know. If you have any no if you have no doubts, then fine. Otherwise, you can ask me any question if you have any doubts. Okay, regarding the read operation, write operation. If you are feeling that you cannot understand, please let me know. Don't hesitate to ask me the question. Right, right, Ayaz. Because already we've discussed, right? So again, let me explain again. So read and write operation is always parallel, because we are achieving the distributed file system. Okay, so that parallelism could be achieved. So, so okay, this way data is there. only the replication factor. So data is writing, okay, the data is writing here, and this is 100 MB of data. But what you told, that is well and good. I'm not going to again explain the same thing, but okay, let me explain a little bit. Okay, when the write operation will happen, suppose the writing means it will contact to the name node, and the name node will give the information saying that okay, pick the data node 1, okay, pick the data node 1 and 3 if there are two blocks. Okay, now choose. Now client will be send the block, it is divided in two blocks, so block 0 will store here, and the simultaneously in the same time the block B, the second block, also stores here. Again, what will happen for the pipeline, for the replication factor, if my replication factor is 3, what will happen internally, it will be moved, okay, it will be copied from this block to this block like 1, okay, and from here to here 1. This way it will be happen. So this replication is happening sequential, but read and writing is happening parallel. When reading, what will happen, it will be read, just client get the information saying that you can pick the data node 1, so what directly it can read, so it can be read block 0 here, and in the same time it can be picked from the block 2 from here. So parallelly I can read and I can write the blocks, but only the point here is only the replication is happening sequential, one after another. Once completed this one, then it will go for the second or third like that. Okay, this is the so this is the takeaway. uh, the Hadoop read and write request will happen parallelly, but the replication factor is happening sequentially. So what is the roles, I mean, what is the prerequisite of a Hadoop administrator? If you wanted to portray yourself as a Hadoop administrator, actually what type of knowledge you should have? Okay, you should have a little bit of understanding of the distributed computing. As we are going through the slides or going through the course, we can grab this one, we can make ourselves comfortable this one, we can study, we can learn all those things. You can have some little bit knowledge about the Linux file system or Linux operating system. If you have little bit knowledge of Linux operating system, it is well and good. Otherwise, we'll go through it, and you can read some of the PDFs, some of the concepts. Okay, so Linux is must, because most of the some echo is coming. Why, I don't know. Okay, so because most of the time, like 90 above percentage environment, we can have the Linux machine. Upon that only Hadoop can be installed. Okay, so the Linux knowledge is must. You should have some little bit knowledge about the Linux machine. And hardware configurations, like the disk topology, RAID concept. If you know the rack awareness anyhow will be storing, and disk topology also we can study. RAID concepts means how to build the RAID. If you have knowledge, because that can be done by the infrastructure team or Linux team. That, but if you have some concepts about the RAID 1, RAID 2, like RAID 5, RAID 3, all there is a RAID labels, means multiple of disks to combine to form the RAID. So what is the advantage? Means you can extend your file system without disturbing the application. Suppose there is a 100 GB of hard disk. Okay, I have installed one application. If the complete space is full, what can be done? It is very difficult, right? So for that, RAID came into the picture. So RAID give the redundancy, means the failure can be also protected. Plus, I can extend the space of that file system also. If I put the RAID, with that I can put the LVM, logical volume management, also I can do. So RAID can protect the disk failure. Okay, disk failure, suppose you can have multiple of disks. If you combine to form the RAID, like RAID 0, RAID 0 cannot be sustained, only it can be for performance purposes. There are many RAID labels. RAID 1 is mirroring, RAID 5 is very very popular, that is called you know mm, RAID 5 is the label where one disk can be survivable. Means one disk gone bad or get failed, then I can have my data. Okay, I can have my data. So it is like striping with diagonal parity. Okay, there is a parity concept. That way the disk, I mean the data will be distributed. So If one disk gone bad also, I can have my data, and meanwhile you can replace your hard disk with a new one, and you can sustain your data, and that would be very good. If you go for the RAID 1, it is a mirroring kind of thing, means I can lose one hard disk. If I have 100 GB two disks, I can combine to form one RAID 1. I can have the capacity of 100 GB only, even though I can utilize 200 GB two disks, but I can get 100 GB of capacity utilized, because RAID is the concept, like the mirroring is the concept. So if one disk go went went wrong, or something got failed, also I can have the second copy in the second hard disk. That's called RAID. Okay, there are a lot many, I mean, good concepts are there about RAID. If I'll tell, it is one class. So if you have a little bit of knowledge on that, that is well and good. So thorough understanding of when to scale and how to scale, of course understanding of the hardware. So all those things you'll read, definitely will study all those things. Only the thing, you can have some little bit knowledge about the Hadoop cluster, or sorry, the Linux OS. If you know a little bit of the Linux OS, it is well and good. Others I can I can guide you a little bit of the Linux, like basic understanding, basic concepts, so that you'll be comfortable on that, and you can enhance by reading some of the stuffs, some of the PDFs, or you can Google it, so that you can have lot many concepts regarding Linux. Yeah, okay, then fine, no problem. So I'll do that. Okay. Probably tomorrow we'll discuss some of the concept, like the storage part we have done, right? Data node and name node we have talked about, and second name also a little bit of we have talked what is the purpose of that. And tomorrow I'll introduce about the processing component, because storing part we have done little bit. Okay, so storing part done. Tomorrow we can discuss about the processing, means if you wanted to process the job, suppose data is stored, so now the developer's work came into the picture. They wanted to extract some of the logic. Okay, they wanted to apply some of the logic, and wanted to extract some of the business logic, business meaningful information they want to extract, or from the problem statement they wanted to solve that one and get the required information. So that how we can do, or who can do all those things, tomorrow we'll discuss, and we'll install some of the components like Hadoop 1.0 will be installed tomorrow. And after that, maybe on Monday, I'll discuss about the Linux. Okay, one class I'll take, and I'll teach you, or I'll make you understand a little bit of the Linux, how it is, and what type of commands are used, what is the file system, and what is the user administration. All those things I'll teach. Okay. So if you have nothing, today we'll wind up the session here. It is already 1 hour. Okay. So tomorrow we'll discuss about the processing thing. Yeah. Okay. So if you have nothing, no doubts, nothing, then we'll wind up here. Thank you. Thanks for your time. Have a great time. Thank you. Bye bye.